Welcome to the Polar Steam Cool Connections live stream. While we're waiting for folks to join, please post where you are watching from and how many people are watching from your location. We're going to give just a couple minutes and then people can start joining the room. Give them a few more minutes to join and then we'll get started. Thanks so much for all of you for joining us today. Again, while we're waiting for folks to join, please post where you are watching from and how many people are watching from your location. Alrighty, I think we're gonna go ahead and get started. Welcome to the Polar Steam Cool Connections live stream. I'm Jamie Ivory, the logistics coordinator for the Polar Steam program, and we are excited to have you with us today. Polar STEAM is a U.S. NSF-funded program based at Oregon State University that facilitates virtual and field-based collaborations between polar researchers, educators, and artists to enhance science communication and bring polar science to everyone. A recording of this live stream will be posted on our YouTube channel. We will keep the focus of today's event on the science and the experience at the edge of the Arctic. However, I would like to mention that applications for the Polar STEAM Antarctic Artists and Writers program are now open until July 15th, and an artists information session is available to view on our YouTube channel. We are currently recruiting NSF-funded polar researchers for 2026-27 collaborations. And if you are an educator joining us today and wanting to bring an experience like this to your learners, the educator applications are also open. An educator information session is available to view on our YouTube channel. Those applications close August 8th at 5 p.m. Pacific time. If you have questions about our artist, educator, or researcher programs, please refer to the information on our website. Now, today, we are excited to connect with two of our Polar STEAM fellows, Taylor Ohlstrom and Julia Guimond from the field in Prudhoe Bay, Alaska. We will start with a presentation from the fellows in the field and follow that with a questions and answer session. We invite folks to submit questions into the live chat. Our team will monitor those questions and we will address those in the chat and any questions submitted ahead of time through the Google form after the presentation. Now I'd like to introduce our fellows. Julia Guimond is a groundwater hydrologist studying coastal groundwater dynamics along temperate and Arctic coastlines. Her research incorporates field campaigns and uses numerical models to better understand the two-way interactions between groundwater and the ocean. Julia is particularly interested in how sea level rise, extreme weather events, and permafrost thaw impact the health and function of coastal ecosystems. And Taylor Ohlstrom is a high school math teacher who believes that math is a tool students should use to investigate their world. Her mission is to make math relevant for all students and show them that it can help make predictions and guide solutions for global problems. Taylor is spending a week with Julia and her team in the Arctic on the edge. And Julia, Taylor, welcome. Let me go ahead and bring you in here. All right. Julia and Taylor, welcome. I'll turn it over to you so you can show us around your field site and tell us about what you are doing up there along Alaska's Beaufort Sea coast.
Awesome. Hi, everyone. I'm Julia Guimond, so I'm an assistant scientist at Woods Hole Oceanographic Institution, and I'm here with Taylor.
Hey, y'all. My name is Taylor Ohlstrom, and I teach high school math down at Lakeside High School. Shout out to all the Vikings who are out there. Down in Atlanta, Georgia, where it is much, much different than where we are up here.
All right, so we're hoping today to give you a bit of a tour of our field site. We had high hopes of showing you our actual field site, but things have been a bit out of the ordinary up here in Alaska. The freshet, or the spring thaw, when all the snowmelt and ice flows into the rivers and flows down to the coast, it is weeks later than usual. So we have actually been cut off from our field site for the past 4 days, and we're not sure when we're going to get back here. But the thing about what we're studying is that it's happening along coastlines all over the Arctic. So we're actually at another field site that is showing very similar dynamics to what we're studying. And that gets us to what we're studying here. So I'm going to turn my screen around, hopefully, while I talk about this. So we're studying saltwater intrusion along these high latitude coastlines. And saltwater intrusion is when saltwater from the ocean comes into these terrestrial environments that are only adapted to fresh water. So when you get high water levels, either from the ocean surge events, high wind events, that water floods the tundra that we're standing in, and the salt gets into the subsurface. And so this project is really focused on understanding when salt comes into this Arctic tundra environment, how does it change the chemistry in the water below the ground surface, or the groundwater? How does it change the greenhouse gas fluxes? How does it alter the permafrost below us? So permafrost is ground that has been below freezing, or 32 degrees Fahrenheit, for 2 or more consecutive years. So standing below me, where I'm standing right now, is tens of hundreds of meters or feet of permafrost. And when you have salt come in, it can alter the distribution of the permafrost in these upper layers of the sediment. And so with that, I think we're going to give you a little taste of what everyone is doing. But maybe first, I'll show this from the sense of what we're thinking about. So it's really early in the season here, right? When we first arrived, there was snow all around us, but it's been a warm few days. And so where we're standing right now and looking at, this is tundra. This is Arctic tundra. In a few weeks, all of these grasses will be, and lichen will be alive and green, and this will be a much more vibrant, healthy system. And as we look to the ocean, so this is Prudhoe Bay. So as we walk towards the system, we can see that the vegetation starts to change. So all of this is driftwood. This is an indicator that the ocean at one point, or many different points, has flooded this area and deposited sediment and salt water into this area. And so now as we walk along this transect and going to the coast, this is some of the team taking some transects, and I'll let them talk in a second. We see that the vegetation starts to die. So now you see what is pretty close to mud flat. It looks almost like a putting green in the spring, rather than some bushy grasses. And as we move even closer to the ocean, you can see these mud flats still are prevalent everywhere we look. So this is the system we're studying. We like to call it this contrast between the healthy tundra, which is the Shire, and this very dead, degraded tundra, which we call Mordor. I personally like to call it the Pride Lands and Elephant Graveyard because I think the driftwood looks like elephant bones, but depends what you're into. And so on that note, I want to give some of the team members an opportunity to chat about what they're looking at and some of the things that they are doing here in the field. And so with that, I will start with the lead now.
It's not that warm.
Maybe, nope, you need to talk a little louder. Sorry, everyone, we got some wind issues.
Okay, so I'm taking, it seems like it's very close to me. I'm close to personal view of my stock coming out of my tail.
It's cold here.
It's pretty cold. It's pretty cold, but relative to the winter, it's pretty warm. And so the top layer of soil is thawing. And so I'm measuring what is the depth of that thawed soil and where is the permafrost relative to the surface. So I've stuck this thaw depth probe into the soil and I'm measuring, and now it hits the bottom and it feels like I hit some ice. So now I'm going to take a measurement and then I can find out how deep the permafrost is. And it's, well, I have to do some subtraction, but if you about 30 seconds. So here in this graded area, we see bigger thaw depths because the salt water is priming the tundra to thaw more.
So how deep was it up in the healthy area in the Shire?
It was less than an inch up there.
Whoa, frozen to the top.
Frozen to the top. It feels, when you're walking on it, it feels like you're walking on ice. But down here it's pretty soft. You can see it. And yeah, we have much less vegetation.
So why are we getting deeper thaw depths here?
Yeah, well, the salt has an interesting chemical kind of reaction when it hits the ice, right? Because if you think about when your sidewalk at home gets icy, you put some road salt on it, right? And the road salt lowers the freezing point of the water, and so of the water or the ice, and so it promotes the ice to melt so that you don't slip on it. The seawater is doing a similar thing here. It's making the permafrost thaw at a lower temperature, and so it takes less heat to thaw it than it would normally. And so the permafrost here is melting more kind of easily than it would be in an area without salt water.
Awesome. Yeah, thanks, Lena. So Lena's on team, what we call Team Hydro. If we were at our field site right now, we would be showing you a whole bunch of monitoring wells which is essentially just a PVC pipe stuck in the ground that have sensors in them that are continuously recording the water level, the water temperature, and the salinity of the water. So unfortunately, we can't show you those here, but that provides a really awesome insight into what's happening in the groundwater and how it's exchanging with the surface water in these flood events. And we also have these really cool temperature probes that will give us the soil temperature at multiple different depths, so we can track that the layer as it thaws over the course of the summer and some of these different physical aspects. And so now I think we'll transition from Team Hydro to Team Biogeochemistry and hear a bit more about what they're pulling out of the ground. So, all right, camera's on you two. You have to talk loud and I have to get close.
Okay. Hi guys, my name is Liz. I'm also a postdoc. I'm at the marine biological. Great. This is my amazing advisor, Jeff. Hello. And we're pulling up water from the ground. We're going to use this little sensor to measure the temperature and the salinity that Alina can use when she's trying to understand this transect that we're taking right here. We're also going to pull up water to measure things like nutrients and carbon, because we're wanting to understand how that addition of salt water is affecting the actual water chemistry. So yeah, we're team biogeochemistry, and we're gonna pull some water for you guys.
Right. So we've inserted this thing we call a sipper, which has measurements on it that show how deep we pushed it into the sediment. This one's in about 15 centimeters. And I'm going to hook this syringe up and I'm going to create a vacuum. I'm going to suck water out of the ground. See it? You can see it filling the syringe here. And then we're going to measure the salinity and temperature and oxygen levels. Got a little bit of water there. Oops. And then we're going to just go ahead and just measure that.
Okay. So the temperature is about 3.6 degrees Celsius, very cold.
Just above freezing.
Yeah,
Right?
just above freezing. Yeah.
And we're getting a pretty high, what we call conductivity, which we later relate that back to salinity. So we're in a salty area.
What's the conductivity?
It's 21,430.
Okay, so almost half of what seawater is, which is pretty salty given we're in tundra. We're standing on lands that should be fresh. Awesome.
Yep. And then, right. So then we take the same water, some of the same water that we measured, conductivity and temperature, and we filter it. We filter it in a bottle and we take it back to the lab and we measure nutrients and organic matter. And the idea is we get the particles out. We filter out the particles, so we just have the dissolved stuff in there, and then we measure it on various instruments to get those. And the reason we're interested in nutrients is because the nutrients like nitrogen are really important for the things growing in the coastal waters, the algae or phytoplankton. They're really the fuel for the base of the food web. And the same with the organic matter. And so we're trying to understand how this stuff that's in the ground, ultimately, which is flowing into the ocean, is contributing to the ocean's fertilization. All right, so I'm going to put a filter on here, get the particles out. Right, see, it's really cloudy, and when we push it through here, the water that comes out the other end, I don't know if you can see that, but it's very clear. It's got a little brown tint to it because it's got dissolved organic matter in it, but most of that cloudiness is from all the particles. Here, pretty clear, a lot different looking than this stuff.
Yeah, big difference.
So
Now that we can take
That's
home
ready
and
to go
give you measurements of things.
great.
Cool.
Thank you.
Thanks,
All right, so while we're down here, I thought we would just quickly walk to the coast, and you can probably all tell that it's pretty cold if you see this video shaking because my hand is exposed. But just wanted to give everyone a quick view. This is Prudhoe Bay, so it's not quite the Arctic Ocean, but connected to it, and we still have quite a bit of ice out on the lagoon, but one of the most beautiful things out here is the ice. So wanted to show a bit of that. And yeah, so this team right now, you can see this is a meter tape we have set up. And so every few meters, every 2 meters, we're taking bow depth and an RTK point, which is really just a really precise location and elevation point, as well as a salinity measurement. So this mapping gives us a nice relationship between elevation, thaw depth, and salinity to help us understand the physics.
Talk about the gem too that y'all normally have out here.
Yeah, so if this also was our regular site, we in addition to some things we've talked about. We use some geophysical instrumentation because, as you can see, it's pretty labor intensive to get water out of the ground. And there's other ways to get information about the subsurface salinity or the different sediment characteristics. So we can use geophysics to capture some pictures of the subsurface and use that to infer salinity. That's best used when you have both manual measurements, like everyone is collecting now, with that to relate them to each other. And then the last part of our team, one of the things we're thinking about is not just how the saltwater changes system physically and chemically, we also really want to know how does it change the greenhouse gas fluxes to the atmosphere. As you have these coastlines degrading, this tundra really changing its composition, how does that impact how much carbon is stored in the subsurface and how much carbon or methane is released to the atmosphere? And so we have our collaborator here, Jackie, who's gonna tell us about her awesome, incredible sensors.
My name's Jackie Hung. I'm a research scientist at the Woodwell Climate Research Center. I'm an Arctic ecologist by training, and I'm interested in how the soils, what's happening in the soils is affecting the vegetation and what comes out of the vegetation in exchange with the atmosphere. Because what happens in the ground and on the Arctic vegetation doesn't just affect what's local to the environment, but can be transported around the world. So here we have, in this briefcase, a carbon dioxide or CO2 and methane or CH4 analyzer. Those are two types of greenhouse gases that can trap heat from the sun's radiation and warm up the planet, also known as the greenhouse gas effect. So what I do is I'll put these chambers, look kind of like mini greenhouses, the tapping to them to the instrument. And when I put them on the ground, and basically creating this little chamber that then can measure gases coming in and out of the ground. So sort of like seeing what the earth is breathing in and out. And with plants and vegetation, in this type of measurement, when it's clear, we're measuring what's called net ecosystem exchange. So both photosynthesis and carbon dioxide uptake by plants, but also what the plants and the soils are breathing out, known as respiration or ecosystem respiration. And the balance of that tells us how much carbon or greenhouse gases are being put into the ground or how much is coming out of the ground. And then when we pair that information with all the pore water measurements and the thaw depth information, we're able to say whether it's certain nutrients that are in the ground that are affecting how the earth is breathing. We can say whether the deeper thaw across the growing season is contributing to more greenhouse gas emissions or uptake. And that gives us a better picture of all the processes that are affecting, including saltwater intrusion and storm surge that are affecting the Arctic tundra.
Awesome. Thank you. So at this point, I'll turn it over to Taylor, who's now been with us for a few days in the field and unfortunately not exactly in the fields given our change in plan, but to talk a little bit about her experience on this team.
Cool. Thanks, Julia. So like I said, I am a high school math teacher by trade. And if you would have told me, I don't know, even 5 years ago that I would be up in the Arctic with Julia and her team, I would have called you insane. Spain from Atlanta, it's obviously very different. I think some of the biggest things that shocked me when I got up here was first just looking at what the tundra looks like. I had in my mind that the tundra was going to have a whole bunch of snow and we would be out here in like, I don't know, snowmobiles or something, driving around. But yeah, when we actually got out here, as you saw from Julia's description and the video, that it's actually pretty grassy. Obviously, everything is still dead because we're just coming out of winter up here. But yeah, there's a lot of grass. There's a lot of mud. Actually, one of our team members fell in the mud earlier today because you get real stuck. It's real deep out there. And it is very, very clear that the saltwater has intruded the tundra. You can almost see at this site kind of like a clear line as to where the saltwater has come up and affected the plants and all of that versus where it hasn't come up. So it's very, very visible. Some of the things that I've learned while just being on this project for the short time and working with Julia is what is happening up here is actually happening a lot of other places. For me, closer to home in Atlanta, where there is saltwater intrusion happening along all of the coastlines, but just obviously looks really different because in Atlanta we don't have thaw depth. I don't think we even know what that means until coming up here. But this is a real problem that's happening everywhere and affecting different sites differently. So hopefully with the work with Julia and her team, they can kind of see how it's affecting the Arctic. And she's got a couple of other projects as well that's looking at this in different spots. But hopefully gain a fuller picture of what's going on and what that means for the ecosystem up in the tundra. That can also like have implications for other places around the world. One of the other things that I've learned a lot from the team is that science is really accessible to everyone. I was really intimidated coming up here with her team because I hadn't done science since I was probably in high school. Doing with the tools that they have is something that anyone can come up and do with a little bit of training. So for those of you that are afraid of science or feel like you're underqualified or anything like that, I promise you, you aren't. I have not been in a science class since I was in high school, and they were able to help me hop right in and help out and all of that. So that was really cool. And then the last piece is, of course, for me as a nerdy math teacher, is I love all the data that they're getting, and from a whole bunch of different avenues. There is Jackie, who you saw with the big suitcase. She has a whole bunch of really cool data on the gases that are happening. Liz and Jim will have data from what the pore water is doing. And then Julia and Alina will have a whole bunch of data on thaw depths and salinity. And they are doing a whole bunch of incredible mathematical modeling to see how all of those are playing together to get us a full picture. I think it's really cool that they are trying to integrate so many different aspects of the science instead of just one thing, to really understand the implications of saltwater intrusion up here in Prudhoe Bay. So I have had a phenomenal time up here with the team, getting to learn from them and the passionate work that they are doing. I'm not sure that I would visit Prudhoe Bay as a tourist destination. I'm not going to lie. It's kind of interesting because there is that we are on an oil field. There is oil field infrastructure. You can't really see any of it from where we are right now, thankfully, because it would also be a little loud. But yeah, that's really the only thing that's up here is the oil stuff. And Julia's team and a couple of other scientists. So yeah, I've loved it. I really enjoyed being up here. I'm not gonna lie though, I do miss my warm weather in Atlanta a little bit. It's a little chilly today. But yeah, it's not raining at least. That's not the big one.
Sunny skies.
Sunny skies. So Jamie, I think we are at a good point to take questions if you have any for us, or if you want to put them in the chat. I'm not sure what the best route would be.
Oh, perfect. Thank you both so much. That was really, really awesome. Loved getting to see all the different sites and meeting all the different team members. That's such a great way to remind everyone that science is very collaborative and you need a whole team of people to answer some really important big questions. Can't just be done by one person. Um, yeah, so also really love the nickname of the healthy, unhealthy sites. And the
There's a nickname
options.
for everyone, you know?
Yep.
Yeah.
Rings fans, Disney fans.
All right, so we do have some questions that came in the live chat and also some that was posted ahead of time through a Google form. A reminder to everyone watching,
Awesome.
please go ahead and post questions in the live chat. We'll answer them now. We had a question from Ava from Texas. She wanted to know how long have these hydro and biochemical monitoring systems been running? And what kind of historical data do you have to compare these measurements to for this location?
That's a great question. So we're now in the second year of this project, of a 3-year project. So really the samples we're taking this year, this is the second trip. So not a long time series, but the reason that we sort of wrote this proposal and started this project is that Jim has been coming to this site and I have been coming to this site being our actual field site, not standing right now, since about 2022. And when we first got to the site, we were studying some slightly different hydrological processes, more thinking about the water moving to the ocean rather than the ocean coming into the tundra. But our initial and baseline data that motivated this project. So a pretty short time series, but all the more reason to hopefully get a lot of good data this year. And then, so we have, I meant to say this earlier, we have a trip in July and a trip in August up to the same site to collect similar data, and then the same program next year. So next year we'll be back up again in June, July, and August. And so over the course of that whole period, we hope to have not only a great understanding of the sites within one point in time, but a 3-year time series of measurements that we're taking.
Awesome. Yeah, time series has to start somewhere, right? So
yeah.
glad that you're starting it because those are so valuable, those data sets. So thank you for thinking of it and getting it rolling.
Yeah, and things change quickly here. So even over the course of a few years, even coming here since 2022, we do start to see differences in the vegetation and those processes. And all the more reason to hopefully extend the time series after 3 years.
Yeah, totally. This question came in for Taylor. What have you learned in the field that you think you can bring back to your students in Georgia?
Yeah, great question, because it's obviously very different up here. I don't know the last time I wore the coat that I'm currently wearing, because it's very warm. I think some of the things that we started looking at, particularly in Georgia, is, like I said earlier, this is a problem that is happening everywhere. It just might look a little bit different. So one of my kind of initial thoughts that I definitely need to look more on when I get out of the field is maybe doing some comparisons between the data that Julia and her team is collecting versus what saltwater intrusion might look like on the Georgia coast, so around Savannah, or potentially even Charleston or some places up in Maryland or Florida, because like we said, it's everywhere. So seeing if maybe there are some differences between what is happening in the Arctic versus what is happening along the Atlantic or mid-Atlantic. But I think the cool thing is that if there are numbers and data, we can do stuff. We love to do a lot of modeling, a lot of predicting, seeing if things actually make sense. So I think that's kind of my initial thoughts. And Julia has been really great of just even sharing some of the data that some of my students have worked with a little bit already and have started investigating saltwater intrusion. So yeah, I think that's the initial thought. I didn't know about Jackie's work either with the greenhouse gases, and that is also super interesting and obviously something that can be measured anywhere we go. So that's another thought that I have as we're thinking about coming on back.
Very cool. Would you say for people that aren't living on the coast, are people that live in the coast, like in Georgia, do they know about saltwater intrusion? Is that like a common thing that people know about?
We are actually pretty far inland where Atlanta is. So that's another kind of area that I need to take a look at. But in some of the more popular mainstream media sources, this is something that has been written about because obviously along the Southeast Atlantic coast, it's way more, there's way more people than there are up here. There's no one up here besides us. And so it becomes some different problems with like wells getting saltwater intrusion and then the wells eventually having to be shut down because there's too much salt in them to be usable. Or some of the other things are ghost forests that definitely happen more where we are, or farmland that becomes, that's ruined and some of the farmers losing tens of thousands of dollars because the salt water is coming on in. So I think people are definitely talking about this. Again, obviously a much different context because there's a bigger human impact happening. But yeah, so I think it's something that's being talked about more inland. It's not something I had heard of before I joined Julia's project because I've never lived along the coast. But now that we're seeing that things are getting affected, one of the things we talked about with my students is some of the farming that's happening up in Maryland. The farmlands are getting affected, which then could have an impact on food sources all around the country, depending on where those farmers ship their crops. So I think it's coming. It's something that all of us need to be talking about because it's not that it's, you know, a problem in the future. It's here and now.
Mm-hmm. Yeah, yeah. A question came in from Aaron. Aaron wanted to know, are the data sets available for other educators to use in the classrooms?
The data sets are not yet available. So we have some data that will be available soon. My postdoc Alina is publishing some of the really cool temperature data with thaw depth and different dynamics. And actually that was the data that Taylor and her students looked at. A lot of this data won't come in until the end of the summer, right? So we're taking point measurements now, but a lot of what we're doing is deploying loggers and sensors that will give us sort of this year-round picture. Data eventually becomes available, especially after sort of the long process of QA/QC and analysis. So eventually it will be. Some is available, and feel free to reach out and I can direct you to those links. But definitely more in the future as we hopefully arrive back in August with some sensors that have recorded data. It is fieldwork though, and you never know.
Yeah, totally understand. And for viewers that don't know, QA/QC, that's like doing a quality control and making sure that the sensors are producing numbers that make sense, that there wasn't an error in the collection. And I will say to viewers too that Taylor will be producing some kind of product that can be used in classrooms, and there might be some data that's involved in that from Julia's work. So stay tuned and look out for that as well, coming in the future. Here's another question that came in. How does it feel to perform important monitoring like this right alongside an oil field? Like, it sounds a little complex. It's like nature versus like Superman made.
Yeah, that's a great question. It's something we've had conversations about in the cars, and something I've been asked about quite a bit. It's difficult, right? Because we use planes to get here, and in our just everyday lifestyle at home. So yeah, as sort of bothersome as it is to see when you're here, and one of the things that we've done since the bridges have been all closed and we can't get out to our site is spend a lot more time walking around or not driving around the oil fields and looking for sites that we could do sort of an inland end a comparison, so to speak, from our coastal site, and seeing how many areas really are this time of year affected by dust. So I don't know if you can see, these roads here in the Arctic are elevated, and they're probably can't see too well, but there's a lot of dust. It's, despite water being everywhere, it's really dry, and the dust flies into the tundra and it coats the vegetation, and so the vegetation are affected. There's different nutrients that are introduced to the system, and sort of seeing the scale at which that is really affecting the tundra close to the roads, which are everywhere, is frustrating and upsetting. But yet again, it's I flew, it took us 3 planes to get here. It'll take us 4 to get home. It's a tough place to be in. And I don't know if you want to add anything. We all talk about it and wrestle with it and a lot.
Yeah, it's
quite
definitely
frankly.
It's definitely a little weird to be doing the data collection and looking at how the saltwater is affecting the tundra while around all of this industrial stuff. But I think one of the cool things that I've noticed as we like go for meals, we are staying like with oil field workers. So we definitely are not just like isolated. But one of the cool things that Julia and her team always tries to do when we are at meals or whatever is talk to some of the oil field workers and just kind of like, I guess in a way, humanize everyone. That I feel like sometimes it might feel like that science can get pitted against different aspects. But I think they do a good job of sharing their work. And a lot of the oil field workers are interested in what they're doing and want to know more. And they are all super friendly. So I don't know. I think it's making the best of the situation. And I don't know if Julia and her team could do the work up here unless the infrastructure for the oil was up here. I mean, it would be really unfortunate to sleep out here because it's cold, but
I think that's another important point. We're so data limited in the Arctic, right? Some of these points that we're getting are some of the first points ever, and to get out here, we're using this oil field infrastructure. So making the best of it, and it allows us to drive out to our site, and it allows us to sleep in a warm hotel and with a warm shower at the end of the day,
and eat good food.
And
a
eat
lot
good
of food.
It just makes it really possible and makes these coastal sites accessible. So there's 2 sides of the coin, and making the best of it.
Yeah, definitely. Very relatable to lots of different branches of science, oceanographers being out on research vessels that are, using fossil fuels to
Yeah.
get the science done. So yeah, taking advantage of the resources that are available to you to answer really important questions, is just the really bright side about it all. Well, I do want to be respectful of everybody's time, especially you, Julia and Taylor. Thank you all so much. And all of the team, thank you for being here and joining us today and taking the time out of your fieldwork to talk to us. We really appreciate it. And we hope that the roads open up and you can finally get to those sites very soon.
We do too. Yeah. But thank you all for tuning in, and maybe one more pan out to show this really, really cool place. You can see some
It's beautiful in a weird way.
Jackie runs out of the frame, but yeah, thanks Polar Steam and Jamie for facilitating this. And if anyone has follow-up questions, I have a website. We have a science Instagram if you want to follow along. When we're in the field and at our field site, we post. Otherwise, we just post sad photos of us sitting at a cafeteria table waiting to go in the field. But all of that information can be found online, or maybe even put in the chat. Yeah.
Yeah, that would be great. If you share those, we will be sure to put them in the chat with our YouTube video. Thank you.
So, well, thank you all for tuning in.
Yeah,
thanks
so
for your
much.
time.
Yeah. Thank you both. And thank you to all of our viewers. We really appreciate you joining us and asking such insightful questions. There are many ways that you can engage with Polar Steam. You can subscribe to our this YouTube channel and follow us on social media at Polar Steam Team to see our blog as well as our educational resources and program information. Please check out our website. A reminder that a recording of this live stream will be posted on our YouTube channel. And thank you again for tuning in to Polar Steam's Cool Connections today. Thank you all. Bye-bye.